I was on a fairground with the kids, so of course they asked for cotton candy, and I noticed that some droplet of saliva, because they are very young, make some droplet very spherical. And so I say, oh, okay, maybe I have a case. I take the fiber, I put a droplet on it, and the droplet will stick on the fiber, but it will eat the fiber too. So what will the droplet do? And so I try, and it makes something interesting that the droplet doesn't fall down, but keeps on going up, as if the droplet wanted to eat all the fibers. So when the droplet is at the end of the tip of the fiber, you have one line of contact of the bottom and one of the top. And so when the fiber is diluted, actually the distribution is not homogeneous, and so it will break there. And so you lose one contact, and so you have only this force that acts against the gravity, and it's like an extra force. And qualitatively, it's like that we explain the system, but we have still to do a lot of experiment. I need a machine to do cotton candy, so I buy one. A good way to have a lot of friends in the department, so because when we do experiments, we have to produce a lot of cotton candy, so everybody, all the departments are our friends. The process to make the candy floss is already a fluidic problem, because you have a solid sugar and you transform it into solid fibers, and in between there is it passes by a liquid phase. So the head of the candy machine is a hot head that is turning very fast. Acceleration on the border is nearly 300 times the gravity of the Earth, and it eats the sugar that's turned to be liquid, and because of the acceleration, this very viscous liquid manages to pass through very small holes, and so that makes the fibers. So we measure the thickness of a fiber is about, in the candy floss, is 50 microns. And so if you take the density of the sugar, you can evaluate the length of the fiber you have, and so it's about 3 kilometers. So it's a good way to have a big fires. And more surprising is the surface. When you start with the 30 grams of sugar is very small, so the surface is small. But if you evaluate the surface of contact between the fibers and the air in the candy floss, it's 1 square meter. So it's a very large area of exchange. That's why it's able to capture the humidity of the air. It's very efficient. When you go in a fancy ground, you never see people that prepare a lot of cotton candy, because they will collapse. They put it into a bag or into something in plastic to avoid the exchange with humidity. So now we have seen we are focused on one fiber, but the collective motion is also fun. On the video, there is at the moment we draw one droplet, and we can see that the droplet separates into several small ones. This is something I would like to understand, why the liquid is happy to separate spontaneously at this moment.